Alright, so let's get on with it. Last time the topic that we learned was equation of the line. Equation of the line was y equals to mx plus c, where you had to find out the equation of the line. Either you're given 2 points, or probably where you're given a graph with a line, and you had to select 2 points from there, find out the gradient, and then find the equation of the line. Plus also you had to find out the y-intercept, which is c, correct? Today the topic that we're going to start is something that the examiners love to give in your examination, right? This topic is and perpendicular and parallel lines. So how do you find out what would be the perpendicular or what would be the parallel lines, right? So let's get on with it. First we'll start with the parallel lines over here. Parallel lines. So if, for example, the question is given to you y equals to 3x plus 4, you have to tell if this particular line is parallel to 1 over 3y equals to x plus 5. So now you have to show if both of these lines are parallel or no, right? How do we get that? We get into that with a very simple technique. Always remember that with parallel lines, so let me draw it over here so that it'll be easier to understand. So if this is a line and this is a line, then we can say that both these lines are parallel. So how can we say this? We can say this by a simple rule that this equation will have, or this line will have the equation of y equals to, let's suppose, 2x plus 10. So this line will, so over here what's happening is this is your gradient, right? We already know this, that this is your m, y equals to mx plus c, and this is your m. So this is your gradient. If both of these are parallel lines, then your gradient for this line will also be 2. So in parallel lines, what happens is that m equals to m, both the gradients are supposed to be the same. If gradients are same, that means these lines are parallel. If gradients are not same, then these lines are not parallel, very simply put. C does not matter very much. Why doesn't C matter very much? Because if you see, if I'll stretch this line a bit, so over here C would be, let's suppose, 8, and over here if I stretch this a bit, your C might be 10. So this would be the difference between C's or y-intercept. But C's can be different or y-intercepts can be different, but gradients are supposed to be the same. So if the gradients are same, that means that we have got ourselves parallel lines over here, or parallel line rule is being used over here, very simply. So they might give you different kind of questions for parallel lines. Let me erase this. So for example, they might tell you that we'll get on to the questions. So there's a question over here for parallel lines. We'll do this question, but the major rule that you have to remember is parallel lines mean that gradients are the same for both the lines, very simply put. The second topic, the second rule that you need to remember. So now in this video what we'll do is we'll do parallel lines, perpendicular lines, and lines intersecting each other or lines crossing each other. We'll be learning all three of them in this particular video only. And obviously we'll be doing questions along with them. Let's try doing perpendicular lines. So in perpendicular lines, if for example a curve is given to you or a line is given to you this way, a perpendicular line would be given to you this way. And mind you, you always have to remember that whenever a perpendicular line is given to you or told that this line or L1 is perpendicular to L2, this means that L1 and L2 are making a 90-degree angle, very simply put. So you have to remember that perpendicular means 90-degree angle. I do not know, a lot of you might have not done it yet, a lot of you might have done it yet, but we will be making a course on trigonometry as well, so we'll be doing trigonometry. Over there as well, what happens is that a perpendicular angle, or perpendicular is also known as opposite, so perpendicular angle is the one which is right next to the 90 degrees. So this would be your perpendicular or opposite. Perpendicular or opposite are both the same thing, right? So if a question like this is given to you for coordinate geometry, how will we solve this? So let's suppose that this is given to you as y equals to, and this is a downward sloping curve, y equals to minus 3x plus 5, and a point is given to you over here at L2, which is, let's say, 8 and 9. Let's say, okay, so 8 is x-axis and 9 is y-axis. Now you have to find the equation of the line for y, or for L2. How will you find the equation of line for L2? What you will do is, you will put the same formula again, y equals to mx plus c. Instead of y, you will put 9. Now this is for L2, mind you, okay? So now this is for L2 that we're finding out. Y we will keep as 9, m we will let be as m for now, x we will keep as 8, and c we will let be as c right now. Now we have to find out m. How do we find out m? So the formula for perpendicular lines, or the gradient of the perpendicular, is m1 times m2 equals to -1. This is the formula for the gradient of perpendicular line. So gradient of perpendicular line, m1 times m2 equals to -1. Let's use this formula and let's try to find out the gradient of L2. The gradient of L1 is given to you as -3. We already know that, right? So -3 times m2 equals to -1. m2 equals to -1 over -3. Negative cancels out. So m2 equals to 1 over 3. Or gradient of L2 is 1 over 3. Notice this is a positive number, so we know that L2 is an upward sloping curve, or it's an upward sloping line, because of which the gradient would also be positive. So we're on the right track now. 9 equals to 1 over 3, 8 plus c. This becomes 8 over 3. So 9 minus 8 over 3 equals to c. We will find out this number. We then will know our c. This becomes, I think, 2.66. So 9 minus 2.66 gives you 6.33. So 6.33 will be your y-intercept for L2. So your equation of the line for L2 will be y equals to 1 over 3 x plus 6.33. And this will be your equation, right? This is how we can solve a perpendicular line question or a perpendicular gradient question. We will be going on to the questions over here. This question is given to us for perpendicular line, so we'll be doing that. Let me just finish one more thing and then we can move forward along with it, right? So after perpendicular, intersecting lines. So this one is fairly very important. Intersecting lines, we have to know how to find out the coordinates of intersecting line. A lot of times what happens is one line is given to you, as for example this. One line is given to you, for example this. The equation for this line, as this is an upward sloping curve, would be given to you as y equals to 2x plus 1. And the equation on 2x plus 1 is fine, and the equation for this line would be given to you as there's a downward sloping curve, so y equals to minus 3x plus 12, let's suppose, right? Now what you need to know, or what you need to find out, is what is the coordinate of this intersection or point of intersection. How will you find that? See, now point of intersection or mathematics generally itself, it's not just in math as a subject. Math is used for economics as well. So I just remember when I see this is that when I teach economics as well, over there as well, I have to know that demand and supply, when both of them are crossing each other, that is basically the equilibrium point, or that is the point where the customer is willing to buy and the seller is willing to sell. So that is basically also an intersection point, right? Exactly that way, this is your intersection point. You need to know what this intersection point is, or what point are both lines crossing each other. How will we do that? How will we do that is we will write these equations respectively. Y equals to 2x plus 1 and y equals to minus 3x plus 12. When I write this in this form, tell me how many of you have a ring in the have a bell in their minds. Yes, exactly. So what we're doing over here is we're finding out the simultaneous equations. We're trying to find out the values of x and y through simultaneous equations. All you will do is you will solve these equations simultaneously, and you will get your answer for x and y, very simply put. We will be doing questions where you will be required to do all of this. You can use elimination, you can use substitution, whatever formula. A lot of my students, they like to use matrices as well. A lot of my students, they like to use differentiation as well. So there are different ways to solve simultaneous equations, but for ease purposes, what we'll do is we'll try to use elimination over here. How do we do elimination? I will keep this as negative, the whole thing. So when I keep this as negative, I get minus y plus 3x minus 12. So this and this cancels out. 3x plus 2x plus 3x gives me 5x, and plus minus gives you minus 11. Minus 11 will go on that side, so 11 equals to 5x, and x equals to 11 over 5. The answer would be, if I am not wrong, should be 2.2. So 2.2 will be your x's value, and all you do is you put x's value in any of these. So y equals to 2, 2.2 plus 1, y equals to 4.4 plus 1, so y equals to 5.4 will be my answer. So this respective point for x and y would be 2.2 and 5.4 respectively, right? There's my x coordinate, there's my y coordinate. This is how you solve intersecting lines, or this is how you solve simultaneous equations, very simply, right? Obviously, if you have any questions, comment on it below. Let me know if you have any troubles. We will make sure that we answer them as soon and as quick as possible. We will go on to the questions as well, so that this understanding becomes more easier to everyone, right?